Okay, welcome to our first architecture meeting for the code that we have so far for our application. What I'm going to do on this is show you the first of the research ticket and actually start to walk through some of the code that we have for this project. I feel like we've done a lot of videos, but we have not shown code. Hold on, let me move this over. All right, so we are here. We're on the research backend architectures, and the done win for this was for us to have the first architecture meeting. So that's what we're gonna have. That's what we're gonna have today. I'm putting it on everybody's calendar, so we got it, and we're gonna walk through the code right now. So let's get right into that. And so this is the solution, two-stroke engine solution, and I'm going to try to use this freeform app. I never actually used it. I think it's a new Mac app or something, but I don't think it lets you do like freeform drawing, so I'm gonna have to do it just by text. So our application, two-stroke engines. I don't have an official name other than that yet, so that's kind of just what we're working with. But the basic gist of the structure so far, and again, if I had to put a percentage of completion on this project, I probably would put it at maybe 20% of like before we get to like a prototype phase. So we have we have a very, very far way to go, but I'm going to minimize all the folders we have so far, and let's walk through it. So right now I have it split up between two projects. So I have my main solution, two-stroke engines, and it's subdivided right now, but it's subject to change, into database and then two-stroke engines, which I'm going to rename that, I think, to be something more appropriate, to be like front end or something like that. But again, we're working on this as we go, right, on the channel. So that's what I have so far. Let's start out with the main project that I started with, the two-stroke engines. So first, right off the bat, you'll see a client folder. This contains basically all the front end, which, to be honest with you, I might rename this to front end. Naming is the hardest thing, I mean, in project architecture. But basically, this is where I have my React front end. So you can see all my components, the TSX files, and everything there. And how this works and how it's able to be included in my project is that I'm using ES-Build. And if you go to where is it? Is it going to show on here? Right here. So if you go to my package.json file, you can see I have my scripts set up and build. So if you did yarn build, when I'm using yarn, it's going to run this command here. So ES-Build index.tsx, and then it bundles it into this output directory. So the output directory you can see here is my www root folder, which that corresponds to here in the distribution and right there. So it's basically taking this app here, this function app, this is or how React app is structured. You can see that it creates its root, okay, and then it renders app. So basically how this works is this is crucial here. So React DOM create root, get element by ID. It's going to take what it sees for this app root, and again, since we bundled it now into the distribution file, index.js, this is the bundled JavaScript from our React project. If you go into the main view of the ASP.NET web app itself, you're going to see app root. Okay, so basically the React app creates this virtual DOM and then puts it where it sees this app root. So this is where your front-end application is actually rendered, is right here. So that's really all it is, and it's a pretty lightweight way to do that. And again, I creating the React app, I did it from scratch, so I don't have all the crazy dependencies you would get with like create React app or any of those templating things. So you can see you can take a look at the package JSON. It's about as minimal as it can be, and I'm trying to keep it that way because it can get overwhelming very quickly. So that's kind of the structure of how the front end operates. And if you go into the front end, let's see, you can see, I just have basic routing set up for the different pages I have currently, and everything's very, very lightweight. I have it divided just into components, general just data types. So these are like all my equations that I got from ChatGPT for the engine, and my API. So the API, what that is going to be is the communication to the backend. So I'm API might be a little misleading, to be honest with you, but that's just a way you got to name it something, right? And I might rename this. A lot of these names are probably going to change for the folders. But so that's the front end, and that's really all it is. Again, so it bundles it into our distribution folder here, and then it's actually physically rendered still on using your index.cshtml, which you get when you make a ASP.NET web app. And so that's that. The back end is just your typical MVC. Now obviously I'm not using like Razor views now because I'm using React, but the core MVC structure is there, right? So for views, you have to have a home folder which corresponds to a home controller, and then you have an index. So your home controller, right, will have an index that returns the view, right? And that view is that index.cshtml file. So that's your entry point to the app itself. And basically how this is going to all operate together is that when you load up the application, it's going to come through your typical pipeline here, right? It's going to add controllers with views, register services, and all that stuff like that. And then it's just going to do your traditional controller routing, right? So, I mean, just pretty standard out of the box things that you would get with an MVC solution. So that's kind of the typical structure of MVC that we're using. We only have two controllers right now. The home controller is both the entry point and also just the general catch-all entry point if we throw something at it that we don't. If we throw a route at it that doesn't register. The engine's controllers, right now I just have it in this controllers folder. I might move it because this is going to be more of like an API controller. It's going to return data to us, so you can see like here, get engine, it's going to return a 200 status with their results JSON, which I just have returning back mock data. It just using standard dependency injection. So I'm just injecting the services that I need for right now, which is the engine service. So if we go to that, we'll go and go to the implementation there. So I'm trying to stick to programming to an interface as much as I can. So for right now, I just have my engine service, and I just have one method signature on there for sync engine data. Sync engine data, the reason I called it sync is because I want it to be as real time as it can be when this application is actually built, meaning that when the engine is running, I want to be able to send diagnostic information to my database and receive it and act on it, analyze it, and model the data as close to in real time as I can be. So my intention with syncing the data is that it's going to be kind of like this ongoing process that needs to run, which is why I kind of went with a pipeline pattern a little bit. I'm still on the prototype phase of that, but I guess I'll go through that now. So if we go into the actual service itself, okay, so right now we have just this, and you're going to see a ton of to-do comments. This is just me taking notes on where I am and what I still have to do, making a list for myself. So the sync engine data method is going to take in this engine model, and if we go to the engine model, it's just a list of all the basically columns that we have in our database for engine details. And this engine model, I think, is just going to be an aggregation of all the engine data that we might need to work with in our application. I want to limit myself to only passing one object around to house the engine model or the engine data. So I'm going to try to use engine model as much as I can and kind of make that my go-to object, if you want to call it that. So the first thing I'm doing in my sync engine data is I'm creating a cancellation token, and that's basically going to act. I'm going to send that down my entire pipeline. So if I ever need to cancel execution due to a timeout, due to an exception, anything like that, the cancellation token is going to be a little more organic of a way to do that, especially as I start setting it up for these pipelines to run in parallel. I need a way to signal different spots in my application to stop if they need to, and that's how that's going to work, right? Like my thought with this is that I'm going to include some kind of either button or some kind of flag that you can set to stop your engine running at a specific point, and I'll need to stop the pipelines as well. So I'll need that set up. So cancellation tokens work really well with this pattern. And so basically you can see here, the first kind of sketch I have is this build pipeline. So I have this engine propagator block, and I'm calling this build engine propagator block method. And you can see I pass in my engine as well as my cancellation token. And I'm trying to use a dependency injection as much as I can for this. And dependency injection is nice because, let's see if I can draw a shape. Is it going to let me draw? Okay. So dependency injection, you start with your root composition, right? When the application actually starts, you're going to basically make this composition, of dependencies. I know that's kind of redundant, but if we go, is it going to let me copy this? Okay, perfect. So basically what happens in dependency injection is we start with our root composition. As we make as our application starts up, basically a controller has this more generic iController activator interface, and on that there is a create method. And when that create method is called on our application startup, it basically creates for us the composition of our application, right? So if we have our home controller, that will be the first really of this composition, and then the next was our service or engine service, and then the next would be this engine propagator block. And why this is important and why it's important to think about it in this type of structure is that you don't want to create a dependency. Is this going to let me? Oh, that's an outline. Okay. I'm trying to figure out how to put a shape in here. Yeah. You don't want to put a dependency in engine propagator block that references something way up to, let's say here, your home controller, and you don't want to start going like, my engine service also needs to reference, something over here, like this isolated repository or something. And then you have this relationship here, but then if you change something in the repository, you break the service, and then you break the control. So you don't want that. You want it to be as top down as it possibly can, and that's what dependency offers us to do, the ability to do, is basically, it's a design pattern to produce this top-down approach, in our case using constructor injection to pass the dependencies down as we go, right? So we want to keep this flow as much as we can. It's important we do that because for a number of reasons. One, for clean design, but two, so we don't break anything as long as we're coding to interfaces and we're injecting into the constructor of our services, controllers, repositories, whenever it needs to be put in there. And also it helps us with overall performance when we start talking about databases, because we don't want to be creating a new connection to a database every time we instantiate a new object. We want to pass that connection into it, and that's what dependency injection will allow us to do. So this is the general composition so far in the context of dependency injection. So here, let's go to build engine propagator block. And then you'll see we jump down to this propagators folder within our pipelines folder. I might make pipelines its own project. I don't know if that's necessary, but as I add a lot of these blocks for all the different components of the engine, I might need to, just because it might grow a little big inside this project specifically. You can see here that this propagator block is responsible for assembling all the transform blocks into one unit, this type iPropagator block. And you can see this encapsulation method basically takes the first block and the last block and consolidates them all into this single data flow block, which is super, super nice, but it's very powerful because it uses composition to basically specify the sources and output, and it creates this flow of data. And so you don't have to create a lot of variables and then pass the variables in. It just all kind of works, and it's very, very nice. And pipelines are important. You have to think about it up front a lot, and in our case it's going to work well because I'm only passing the engine model through everything. That's the only object I'm acting on in this engine propagator block. So every transform block that I'm adding is only going to act on on the type engine model, which is going to work out really well. It's going to make this really clean. And it's just going to work really well, I think. So there's a couple options that you want to specify. Propagate completion is important because you need to signal the first block to the second block that the first block is done. Otherwise, you might have this scenario where your second block is waiting because it doesn't know what the first block does. So you got to specify that. Let's see what else. You can see here that so I create the settings, I create the block, the actual blocks, and for this I think I'm going to make a factory, to build these blocks. I don't know yet. I don't know how in depth I want to go with that, and then I got to create the links. I don't know if I'm going to make it some way else somehow. I don't know if I want to make another way to create the links or just keep it manual. I'm not sure, because what I'm thinking for these blocks is that I'm going to have, let's draw this here. So basically the blocks I need to have, just a rough sketch, are carburetor, if I can spell carburetor. The carburetor, piston, exhaust, and I'm not going to list everything because I haven't thought it out fully yet. And that's why we're only at 20% completion. So carburetor, piston, exhaust. Let's have a spark plug be one. So basically every component is going to be its individual block, and the block is going to represent the unit of work that the specific block is going to do. So if we go to the implementation of engine analysis block, is it going to take us there? Nope. All right, I got to go in engine analysis block. Oh, I don't think I'm actually doing anything. I haven't implemented these yet. But you can see I have these two methods that I have build block and execute action. And they're, the execute action is going to be responsible for actually doing whatever work it needs to do, right? So carburetor is going to need to adjust the high and low jets, to adjust the fuel, air to fuel ratio. The piston's we're gonna have to adjust the speed of the piston. The exhaust is, how open is the exhaust going to be? Spark plug, how many spark plugs are there? And what's the burn cycle like? So that's what each thing is going to roughly have to do. And all that I'm thinking is going to go in this execute action method. And I made this interface for iEngine block that offers the method signatures of build block and execute action. So again, they're acting on engine model specifically, so they really should work very well. So if you go back, the reason I did an interface is because in my actual propagator block, I can just call build block on the interface. And I don't actually have to know like any implementation details because I'm just coding to an interface. And I also can inject the type of iEngine block into my constructor, which makes it nice because I'm taking again advantage of dependency injection, maintaining the top-down root composition of my application. So that's why I'm coding to an interface. And if I end up using a factory pattern, I'm gonna need an interface anyway. So it just kind of sets it up, makes it a little nicer. So I have the analysis block linked to the save block, and really like these are like just the two blocks I stubbed out for now until I actually make all the things like you can see here on the left or the right, and then have those blocks. So imagine this would be like the carburetor block is linked to the cylinder block, which is linked to the spark plug. It's going to be a link of steps similar to how an engine actually operates. So my goal is that you could come here and read the links and already have a pretty good understanding of how an engine works just by reading the code, because it's written mostly in plain English. And the reason I want to do it this way as opposed to just defining the methods and then calling them like sequentially is that one, this offers a really easy way to pass engine model all the way through just using because it's highly composable. Two, I can just pass my cancellation token to each block and have one cancellation token for the whole system. Another reason is because that this is going to offer me an easier way to write to make some of these blocks work in parallel. Another reason is I think it's just a little cleaner doing it this way, just because if I just listed a bunch of methods and then I just have a calling method that called the methods, I mean, you could do that, but it would just grow into this long kind of just, list of method calls, and then I have to assign each output to a variable, and then so I think that this design is going to be a little cleaner, and it should be a little more efficient too, and it has to be fast because this is going to be as close to real time sync as I'm trying to make it be. So I think that's really the general gist. So that's really the main block. And again, the service for right now is what is calling that, right? So this gives me the whole pipeline. So, and another reason is because the service now only has to call this build engine propagator, and it has the entire pipeline of work. And now we've set it up in a way where we can send information through that pipeline and not necessarily receive it either, which is a huge reason why I want to do this, because it's going to offer us a natural buffer too. So I may build a buffer block into this beforehand, because if we're sending so much information, we can't always be sending it and then awaiting it and then sending more. We kind of have to just send it and then not even wait for the response. And that's what this pipeline's going to really, I think that's really where the power of this pipeline is going to come in, because if we have this pipeline set up, and we can just post data to it, right? Send async is the asynchronous, and then you can do post, and then that's the synchronous version. But send async is going to be super nice because we can make it not blocking. Okay, we can send as much data as we possibly can through it, and it doesn't matter. The UI is not going to be affected one bit, so it's just going to be spamming this thing with data, and then we can have this running process in the background saying, okay, as it becomes available, let's receive the data. And for right now, for testing purposes, I just have a continue with, and then I'm just awaiting the receive async. That's not what I'm going to leave it as, but to test it, I just have to see that the data is coming through the pipeline correctly. So another part of the prototype is, or the second prototype is, I don't know if we're going to work with a queue, a first in first out queue, like a buffer block. That's one possibility. I don't know if we're going to do a more the queue is really what I'm leaning towards, honestly, for prototype 2 to build into this. So that's going to be the next big part of the back end planning, is setting that up, because once I have that up, this is going to be really, really nice, because if assuming I set it up correctly and I set it up so that it can handle really high throughput and nothing will be blocked. And again, this is the first time that I'm working with this specific like pipeline pattern, and it looks really cool. Another reason the pipeline, I keep mentioning that the pipeline is going to offer me an easy way to make this to be able to write parallel code, is because I'm planning on having multiple pipelines. So I'm planning on having multiple of these propagator blocks, right, that I'm building. So I'm going to have, my engine propagator block, and I kind of been using pipeline and propagator block interchangeably. I don't know if that's confusing, but I guess I'll call it pipeline just because it's a little more plain English. So I have this engine pipeline, right, that's going to handle every aspect of the engine. Ideally, I'm going to have a some kind of social pipeline, right? Posting, receiving, how often does update feed, everything like that. I need some kind of I think that's, I don't know how many I'm going to need, but I think I want to set up so that if I have it, if I know I have more than two, I can run those at the same time, right? Like if I'm running if I'm running my engine on the application, collecting and syncing information, I don't want that. I want my social feed to still be continuing in a non-blocking way. I don't know. That's going to be another big aspect of the back end too that we'll have to figure out. And that's kind of where I'm at. And again, the service is probably not going to stay the same at all. to be honest with you, like this offers me a really easy way to call it for right now, but I don't think I'm going to actually leave it contained in this sync engine data method on my service. I think I need it to be its own. Thing. I'm not sure yet though, because I think the danger I have with sticking to having it in a service, I think I might be backing into a corner, in the sense that I think it might be limited with this, or I might honestly make this a void, and just not I might just have this not return really anything, and then just have it this open, just kind of like this open endpoint where I can send data and then just get like a 200 response back that the data made it to the pipeline, but didn't necessarily go through it, but just it got to its starting point, basically. I think that's what I'm gonna have to do, to be honest with you. I might let's see. may need to change this. How about that? May need to change possibly just not avoid return type, because I'm not going to, but possibly no, just return. I don't know. That doesn't make any sense, but I'm going to leave it at that. So I think I think I'm going to leave it like this for right now, just while I get through testing first, and then I'm going to have to create my, because I think honestly what I'm really after is just, right, an endpoint that I can throw as much data as I want at it, and it doesn't matter. It goes somewhere, it goes to the destination, because the client doesn't care, right? The client just wants to, hey, I want to send information somewhere, and I just want to hear back something, right? A 200 response, a 500, whatever it is, unauthorized. Ideally, just a 200. I'm just going to have an API. I can just hit, and I just get a 200 back. And the client doesn't care what the response is, like what the data comes back, because that's not how this is going to be set up, right? Like, I'm not going to be returning back the same engine model after it's been acted upon. I need a way for that diagnostic information to come through back in a different way, right? Because having that go like this all the time, that's not going to be sustainable. That needs to be throttled in a better way. So that's really where we're at. I think that's really the core structure, at least for right now. Have I made any of the repositories? Okay, yeah, let me talk about the repository pattern that I'm going to be setting up. So I do have DTO objects. So I have the database transform data. Is it data transform or is it database transform objects? I don't know. DTO objects. These are entities that model your database tables, right? And I guess if I want to be fancy, I can make these. I should probably make these record types. Let's change these to records. What I'm thinking about now. Because I want them to be immutable, right? Like, I want records is basically just a fancy read-only class, pretty much. There's more stuff to that, but it's more of a functional programming thing. So these are going to model. These basically tell us that, okay, this is the data that's in that table. We can't modify this file, but we have to do something with it, and that's where this engine model comes in, right? So this is going to be an aggregation of all my DTO objects, basically. So that's what we're doing now. And as far as the actual access to the database itself, again, we're using MySQL, and I have repositories set up, and I'm just going to be again injecting some kind of connection that I can use to query my database and do everything I need to do. So I will be using raw SQL statements. And yeah, I think that that's really about it. I may move the repositories up to the database projects, as well as the DTO objects. That's another thing I still have to do, but I haven't done it yet. Let's put this out here, and let's go up to database. Database is going to handle all my migration scripts. So migrations are basically going to construct my tables, and so both tables are on here: user engines and engine details. I don't have obviously I haven't fleshed out the full database schema yet, but that's what I have so far, and you need some kind of migration to handle that. So I'm using Fluent Migrator, and this is what I'm doing. So basically, when this migration would run, once I set up that scripting part of it, it would call this up command, and then it would create this table if you were moving up. If something happens, you have your respective down command, and it would delete that table. Same for that one. So that's kind of standard deployment related things that you would do, and I think that is it for right now. Again, you can see the state of, you can see the code, you can see the state where we're at. Yeah, that's the crux of this whole thing. There's not a whole lot to show as far as the actual application. Well, you can start it up, but it should run, I think. I don't think I have any errors. So basically, this is a template from Material UI. It's I'm not a big fan of front end like design coding, or it's not really my personal favorite. So if I can get a template, that's what I'm gonna do. So I got this template, and the idea of this, again, this is probably all gonna change. So don't even pay attention to this, to be honest with you. And I'm not gonna show you the engine part yet. It's just not in a spot where it's ready. So basically, I just have my rough routing, my name down there, and buttons and things like that. And then if I were to navigate to API / send data or whatever it is, you could see the pipeline. So I guess we'll do that. Let me go there. So when you make a API controller, it kind of gives you the default route of API. And we'll go ahead and set a breakpoint on here, and that's where my pipeline is. So API / post data. So if we go here and we go API, oh, what in the world? I don't know why it does that. I think it's like something up with Safari. It's like I don't even like hit enter, and I think it like pre-fetches the URL before I even go to it, which is actually bad because I'm not even, I don't know. So anyway, I think, all right, so I hit here, and we'll step into that. So you can see, what in the world? Yeah, hold on, all right, keep going. All right, there we go. Now it'll let me, it should, what in the world? Hold on. I think, there we go. All right. One thing about this Mac Visual Studio is that it's not without its nuances. How about that? Can I step in? There we go. I don't know why. I've had problems with that step in button on this Mac Visual Studio, but this thing's going out of support, I think, in a year, which I guess I'll have to switch to Visual Studio Code. So you can see it's going to hit my build engine propagator block, and it's going to go down, assemble the settings. It's going to build the blocks. If you mouse over those, you can see kind of what it is, which is pretty neat. You can see all the different options you get. Current degree of parallelism is completed, which would be nice. And it gives you data flow block options. And yeah, you get really powerful settings with this, which is also pretty neat. I established my links. So link to, encapsulate. And here's where I'm going to send kind of my fake data. So originally I sent just a mock engine object with all this mocked data with fixture, so you can see all that crazy stuff in there. And then at some point in my pipeline, I just return a mock engine with like 2 data elements changed, and you can see that I did in fact receive it. But the key, we have not. I think that this is still like awaiting its execution. I'm pretty sure, because if I await that, let's mouse over result. Yeah, there we go. These are the 2 values that changed, was compression ratio and scavenging efficiency. So you can kind of see how this is going to work, and it works pretty well. So again, you just have to make sure that all your everything is set up accordingly. All your awaits and everything like that. And see, I'm return back my bad data. So we'll get out of that route. Go back here, and I guess we'll go here for fun. So this is the state of the art operation we have going so far. So basically, this is going to require a tremendous amount of programming to do, but we'll get there. And basically, it's going to be this little bit larger model of every component interacting with each other. But it's going to really, where the power of this is going to come into is going to be the equations, right? So these guys here. So we have a lot of equations that we're going to be using, and we're going to have a lot of data that we can get, and actual like legitimate data from like real engine specs. So, and then we're going to change the pictures, and then we're going to do a lot of stuff. Again, we might be, we might really be at 10%. I don't know if we're going to be at even at 20%. But anyway, so this is the first architecture design meeting. So we will have another one after I complete kind of my prototype 2 and add more to the back end and everything like that. So again, this is pretty realistic to what this job, a lot of meetings. So anyway, I will see you on the next one. Take it easy.